In this video, I will show you how to integrate machine learning model with Streamlit application. It is very easy to use and you can create very beautiful applications using Streamlit. There are total 5 steps that we are going to follow. In step 1, we will create a folder structure. In that, we will have 2 folders, data and model. We will have one app.py Python file, train.py Python file, and requirement.txt. In step 2, we will install packages from requirement.txt. In step 3, we will read CSV file from this data folder. In step 4, we will train model, train.py, and then we will create the pickle object of this model and save it in this folder model. And in step 5, we will write code for Streamlit application. That will take only 5 to 10 lines of code. And then finally, we will run this application and we will test our model. In the end, you will see how beautiful application we are creating in just few lines of code. It is very easy. If you watch this video till the end, you don't have to go anywhere else. You can create any Streamlit application for any model. This is how the folder structure will look like. We will have our folder or our project name as ML Streamlit app. Inside this, we will have 2 folders. First is going to be data. Inside this, we will have our CSV file. In the next folder, model, we will have our model pickle object store. Then in app.py, we will write our Streamlit application code. In train.py, we will train our machine learning models. And in requirement.txt, we will have list of required packages. If you watch this video till the end, you don't have to go anywhere else to learn about machine learning model and creating Streamlit web application. It is very easy to use, and by the end of this video, you will become an expert in creating this Streamlit web application for any of your machine learning models. So let's go and start coding. Let's open PyCharm, or you can even use VS Code, anyone. In Windows, I will type PyCharm. And now we will create our new project. Click here on this new project. And then you can select your directory from here, this location. I'm going to create it on desktop, so I will keep this location as it is. Or if you want to change, you can click here and then change your location, select it from here. I will just cancel it. And here in name, you have to give your project name. So here we will give the project name ML underscore Streamlit underscore app. And then you just have to click on this create button, and this will create a project for us. I will maximize this. So here you can see it has created project, and it has also created a virtual environment for us. And if you want to close this subdirectories, you can just click here. Now let's go to the desktop to check this ML Streamlit app folder it has created. Now let's check. So this is the folder it has created. I will open it. So it is empty now. Let's go back to PyCharm, and now we are going to create 2 folders and Python files that we need. So our first folder is going to be data. Right click here, select new, then create directory, and here you have to give directory name. I will write data. Then we will create one more directory, name is model, new, and then directory, name it as model. Now we'll create 2 Python files. One is going to be app.py. In this, we will write our Streamlit application code. Let's create one more. And this is going to be train we have already created. Yeah, train.py to train our model. That's correct. And now we'll create one last text file, that is requirement.txt. I will click here, and then I will choose file here this time because I want to create a text file. and now I will type requirements.txt. So we have created our project ML Streamlit app, and inside this we have created our folders, data, model, and then Python files, app.py and train.py, and then requirement.txt. Now if I check this data, it is empty. If I open it here, so you see here it has created all this folder, and if I open data, it is empty now. So I will put a CSV file, iris.csv. So I put it here. Now if I go back to this PyCharm, you will see if I expand it, I have this iris.csv. Now let's first give all the libraries that we want to install. So I will write it here. First I'm going to install pandas. So I will write pandas. Second, scikit-learn. Third, matplotlib. Fourth, seaborn. And fifth, Streamlit. Now let's install this. So first I will start this terminal, and then to install this requirement.txt, you have to write pip install -r and then requirement.txt. Press enter. This will start downloading these packages from requirement.txt. So in that meantime, we can start creating our machine learning model. I'll open this train.py, and then let's import first pandas as PD. I will write here import pandas as PD. Then from scikit-learn dot model underscore selection import train test split. Then from scikit-learn dot ensemble import random forest classifier. We will be using this random forest algorithm to classify to which species a flower belongs. And right now you see you are red here because the installation of these packages are still going on. That is why once the packages are installed, we will not see this red line. And to save time, I have already started importing this. So next we will import from scikit-learn dot metrics import accuracy underscore, and then we will import joblib. You see this message, package installed successfully on this right hand side. So I will close this, and here you see discovering binary modules, and that is why it is still red here. But here also in the output you will see we have installed all the packages. Now we are going to read CSV file from this data folder. I will make a variable data, and then from pandas PD I will call the function read underscore CSV, and inside this I will pass our CSV file location. So it is in this folder data, and inside this the file name, which is iris.csv. And then to look at this data frame, I can just call this print method print data dot head, and then to check I'll just run this train.py. Then just I will right click, then you have to click on this train, and this will start the execution. I got this random forest classifier error because there is a spelling mistake, and let me correct it. Now I will run it again. And here in the output you can see the results. So we have this data frame iris.csv. It is a iris flower data frame. We have these features: sepal length, sepal width, petal length, petal width, and based on these features we have to predict the class of this flower. So there are three different categories: setosa, versicolor, and virginica, and we can even have a look at those classes. So I will write here print data, then species, which is our target variable name, dot value underscore counts, and let me run. So here in the output you can see in our target variable species we have these three categories: setosa, versicolor, and virginica. Each of them are having 50 samples, so they are equally distributed. Now you see that this target variable is in string form, but you know that machine learning model doesn't understand string, so we need to convert this target variable into numbers, and for that we will do a mapping where we will define these different categories: setosa, versicolor, and virginica as 0, 1, and 2. So let's do the mapping first. I will write here map species to numerical values. I will call data, and then I will call our species. I will assign the result to this object, data species, or our species in our data frame. So I will again call this data and then species, and then I will call the function map, and I will create a dictionary. In this dictionary I will define the mapping for each of this category. First is setosa. Setosa will be 0. Second is versicolor, and this will be 1. Third is virginica, this will be 2. And if I print this again, so I will copy this from here and paste it here. Now I should see 0, 1, and 2 instead of setosa, versicolor, and virginica. So let me run this, and here in the output you can see we have 0, 1, and 2. 0 is for setosa, 1 is for versicolor, and 2 is for virginica. Now let's prepare our data set for building our ML model. I will write here define features and label, define features and label. In X we will have our feature. I will call this data. We will have all the columns except species, so I will call this function draw, and I will simply draw species column from this species, and then I will pass the axis parameter. Axis is equal to 1 because we have this for column, and Y is our target variable where we will have just one column, which is our target variable species. Now we have prepared our X and Y. Let's split the data set into train test. So I will write here split data into training and testing. So we will have X train, then X test, Y train, and then Y test, and I will call this train test split. Inside this I will pass our X variable, Y variable, then test size, it is going to be 0.2, and then random state is, let's say, 42 here. and then we will initialize our classification model. So here test size you can give 0.3 as well. This is just for example. And then random state also you can take any number instead of 42. But if you want your result to be same as mine, then you can use 42 here. And now let's create a class of random forest classifier. So I will write here train model. I will make an object model, and then I will initiate this random forest classifier, and then I will fit this random forest on our training data set. I will write model.fit, and then we want to fit it on xtrain and ytrain. So we have fit our model. Next we will make prediction. I will write here predict, and we will save the results in y_pred. So I will call this model. From this I will call the method predict, and we want to make prediction on xtest, so I will pass here xtest. And then we can also check our prediction. I will write here print y_pred, and let me run this script. I will run this run train. So now what you see here 1 0 2 1 1, these are all prediction. So it says that the first flower belong to the class 1, and 1 in our case is versicolor. The second class belong to 0, which is setosa. Third class belong to 2, which is virginica, and so on. So these are the prediction. Now we can also check the accuracy of our model. So let's do that. Model evaluation. I will make a variable accuracy, and then I will call accuracy score, and I will pass our y-test and y-pred, and then I can print accuracy, print f-string, model accuracy is, and then I will just pass here accuracy variable. Let me print and check accuracy. So the accuracy of this model is 100%. It says that the model will make prediction every time correct. Now we will save this model as pickle file in this model folder. Now you see that there is nothing in this folder. Let's save our pickle object. So I will write here save trained model. We will use joblib from this dump, and what we want to dump, this model object. I will write here model, and where we want to dump, so I want to dump it in this model folder, model, and what name I have to give, I will give the name as model.pkl, and let me execute this code. So right now you see it is empty. Okay, now we have saved this model in this pickle object, and if I open this model, you see this model.pickle. So we have trained our model and it is ready for web application. So I will close this train.py. I will also close this requirement.txt, and I have opened this app.py. Let's create our Streamlit web application in just few lines of code. So first we will import libraries. I will write here import Streamlit as st, Streamlit as st, import numpy as np, import joblib. Now let's load our model. Load trained model. I will make an object model, and then I will call this joblib. From this I will call the method load, and then I will pass this path, which is model, a folder, and then our file model.pkl or pickle. So we have loaded our model. Next we will create our Streamlit application and we will give this application a name. So I will write here st.title. So how you give title to your bar plot or any other chart, this is how we are giving the title to our Streamlit application. So our title will be, let's say I will write here iris flower prediction model. You can write any title here, and then we will define input features. So what are the input features it will take and give us the prediction. So we will define those input features here, and first will be sepal length, sepal underscore length. This will be st dot slider. So st is our Streamlit, then this slider, and this will be sepal length, and it is in centimeter, and then we can give values. So maybe we can give values such as 4.0, 8.0, 5.0. So these are some of the values that we are giving, which we can change later. Sepal underscore width, st dot slider, sepal width, and this will also be in centimeter, and let's give some random numbers: 2.0, 5.0, 3.0. So these are some of the random values that this sepal width can take. And let's define petal length, st dot slider, and then we can write here petal underscore length. This will be also in centimeter, and the values it can take maybe 1.0, 7.0, 4.0. These are all random values. And the last one is petal underscore width, st dot slider. Whatever I am writing right now, you will see this in the application: petal underscore width, centimeter, and then some random values: 0.1, 2.5, 1.0. Now let's prepare our input data. So this input features, how we are going to pass. So we will pass this input feature as array. I will make one variable. So let me write first prepare input data. I will write here input underscore data is equal to np.array, and then inside this we can create a list, and inside list we will create one more list, and we will pass sepal length, sepal width, petal length, and then petal width. So this is petal width. So this input data will take our features, and based on this feature it will make prediction. So now we will define the prediction class, or we will define prediction or prediction class predict, and we will save the prediction in variable prediction. We will call our model, and model. From this we will call predict method, and this will make prediction on our input data. That means based on these features it will make prediction, and the results will be stored in this object prediction. And then we will create one predicted class variable, predicted underscore class, and then here we will define what does this 0, 1 and 2 means. So I can just maybe go here, no, but here in train.py I can go here, and then I can just copy this, let me copy it from here, and then I can just paste it here. So 0 means setosa, 1 will be versicolor, and then 2 will be Virginica. These are going to be the classes, and then we will call this prediction, and from this we will take the value at index 0. So we have defined our title for this application, web application, and then what are the input features it will take. We have made prediction here using this input feature, and then we are converting those predictions numbers into string or string into numbers, and then lastly we will display the result, and we will write here display the result, and that's it. So st.write f-string predicted iris species, and then since it is a dictionary I will write here double star, and then inside this predicted class and then double star, and then I will close this bracket. That's it, and let's save it. So we have created our Streamlit app. Now we need to run this, so let's run this now. I'll go to terminal here, and then I will write here Streamlit run app.py. Let's hope we don't get any error. Now it has opened our web browser. Do you want to allow public and private network to access this app? Click on allow. And here we are having our Streamlit web application. You see that this is iris flower prediction model, and I will show you from where it is coming. So it is coming from this title, iris flower prediction model, and now you see based on these values it has predicted this class to be versicolor. And if you change these values, and how you have to change it, so you just have to drag in, maybe you can drag to this, that number, you can increase or decrease this number. So right now if you see the species, it is versicolor, but if you keep dragging, if you keep changing these values, you will get some different species here. So let me change. So now you see the new species is Virginica, and if you change again, maybe you will get a different species. Now it is Setosa. So you see that this is our Streamlit web application. Once you have created this app, now you don't have to do anything. Just play around with these values and you will get a different class for each species. So you see that how easy it is to create a Streamlit web application and integrate it with your machine learning model. You can follow all the steps and you can also create your application. If you face any error, please write down in the comment section. I will help you and I'll try to solve your errors. I hope you enjoyed this video. If you like my video, you can subscribe to my channel. Thank you for watching.